3I/ATLS isn't just another comet. It's a cosmic outsider with a trajectory that screams alien origin. When the Mars Reconnaissance Orbiter and Perseverance rover caught sight of it on October 3, 2025, it had just skimmed past Mars. But what really has scientists holding their breath is what comes next, a close brush with Jupiter in March 2026. This isn't a casual flyby, with a hyperbolic orbit that proves it came from beyond our solar system. If you're still watching, subscribe now. You crave more than answers. You seek what lies beyond. Subscribe now and be part of the few who never stop searching. 3I/ATLS is a rare interstellar visitor whose interaction with Jupiter's colossal gravity could end in spectacular destruction, a wild trajectory shift, or an unexpectedly smooth exit. Each outcome is scientifically loaded and completely unpredictable. That looming encounter with Jupiter isn't just dramatic, it's a once-in-a-lifetime chance to study the deep mechanics of interstellar travel. ESA's JUICE spacecraft, though designed to study Jupiter's moons, will pivot its gaze to 3I/ATLS in late 2025, hoping to capture data that could expose molecules not even found in our solar system. This isn't sci-fi. This is raw cosmic reality. From ancient ices that predate Earth to chemistry born in foreign star systems, everything about 3I/ATLS could rewrite our understanding of where we come from, how planets form, and what life elsewhere might look like. This is the terrifying power of a comet that doesn't belong here, because it might just tell us how everything began. You're looking at something that shouldn't be here. 3I/ATLS isn't from our solar system. It doesn't belong to the Sun. It doesn't belong to Jupiter, and it certainly doesn't belong to Earth. It's passing through, fast, foreign, and completely unpredictable. A comet born somewhere beyond the reach of our gravity, somewhere alien, somewhere old, and it's heading straight for Jupiter. Right now, this interstellar object, only the third of its kind ever confirmed, is crossing the final stretch of its brief, historic visit. On October 3, 2025, it swept past Mars, a near miss close enough for NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and the Perseverance rover to catch it in motion. But they didn't just catch a glimpse, they captured a fragment of time, a moment that may never repeat itself, because 3I/ATLS is not coming back. It's on a hyperbolic trajectory. That means it's moving fast enough to escape the Sun entirely. One pass through the solar system, and it's gone. Forever. The orbit alone tells you what you need to know. This comet isn't native to our neighborhood. It came from somewhere beyond, maybe another star, maybe a rogue cloud between systems. No one knows. What we do know is this: it's carrying chemical secrets older than Earth itself, secrets frozen in ice that predates our planet. Right now, the comet is still accelerating toward the Sun. It's perihelion. The closest point in its orbit is coming soon. Late 2025, when it gets there, sunlight will hammer it. That heat, that radiation, could do anything. It might vaporize parts of it. It might crack it open. It might cause it to shine brighter than ever, or completely fall apart. Why does that matter? Because the materials inside 3I/ATLS don't match anything we've catalogued in our solar system. They're ancient, unfiltered, possibly forged in the heart of a long-dead star. And when the sun's heat hits them, they'll reveal their molecular fingerprint, a fingerprint from another star system. That's why scientists are watching closely. Every particle it sheds, every flare, every tail extension. It's not just space dust, it's a direct sample from another world. Not a simulation, not a model, a real physical piece of interstellar matter, up close, observable in real time. And the next key player in this encounter, Europe's JUICE spacecraft. JUICE wasn't built for this. Its mission is Jupiter's moons, Europa, Ganymede, Callisto. But between November 2nd and 25th, 2025, JUICE will have a unique vantage point. It'll be in the right place at the right time to catch 3I/ATLS as it begins its turn toward Jupiter. The timing is precise, the opportunity, unrepeatable. For a brief window, JUICE could scan the comet's composition. It could detect exotic molecules that don't exist in our system. It might even capture signs of chemistry that challenge how we think stars and planets form. This isn't about one comet. It's about rewriting what we think we know about the galaxy. Then comes the critical moment. March 2026. 3I/ATLS passes just 54 million kilometers from Jupiter. That's close. In cosmic terms, it's a near brush with one of the most massive and dangerous bodies in the solar system. Jupiter doesn't just pull with gravity. It warps trajectories, it destroys asteroids, it rips apart comets. Shoemaker-Levy 9 was torn to pieces by its tidal forces and slammed into the planet in a fiery display. And now 3I/ATLS is in its path. No one knows what will happen. The comet could shatter under pressure, it could shed material, break into fragments, or be flung off course entirely. Or it could hold together, sail past, untouched, defiant. Each possibility is a scientific goldmine. If it breaks apart, we learn about its structural integrity, about how interstellar objects are built, how they respond to gravity, how they fracture. If it shifts course, we learn about the interplay between interstellar motion and planetary gravity. And if it passes undisturbed, we get extended observation time, a chance to track an object older than our Sun, as it continues its one-way journey out of the system. But once it's past Jupiter, that's it. There's no return path, no gravitational loop, no orbital comeback. 3I/ATLS will accelerate into deep space, leaving everything behind. All we'll have are the numbers, the samples, the images, the raw data collected by Mars orbiters, surface rovers, and Jupiter's dedicated spacecraft. That data will be studied for decades, because what's inside this comet could explain how planetary systems are born. It could reveal how molecules travel between stars, how life's raw ingredients are seeded across galaxies. If 3I/ATLS contains organic compounds, complex molecules forged in alien systems, it could point to chemistry universal across the cosmos. That means it could also hint at life. Not life on the comet, but the possibility that the building blocks exist in more than one place. That what happened here, on Earth, wasn't unique. That it could happen elsewhere. That it has happened elsewhere. And if that's true, 3I/ATLS becomes more than a comet. It becomes a messenger, a cosmic envoy, something that wandered the void for millions, maybe billions of years, only to pass within reach for a few brief months. We'll never catch up with it again. That's why every second of observation matters. Every data point adds to a profile of the unknown, not just of one comet, but of an entire category of interstellar travelers. We've seen this before. Barely. In 2017, it was Oumuamua. In 2019, it was Borisov. Both passed through. Both offered glimpses. But 3I/ATLS is different. It's the first one observed this closely at multiple stages of approach, from Mars, from space, from orbit around Jupiter. A coordinated international effort. NASA, ESA, observatories worldwide, all aimed at one object, one shot. Because once it's gone, it's gone. This isn't about exploration for the sake of exploration. It's about the long game, about understanding how our solar system fits into something bigger, about finding out whether the materials that formed Earth are common across the stars, or the result of something rare. There's no second chance. We can't fly to 3I/ATLS, we can't land on it. All we can do is watch, analyze, decode, use every tool we have to extract knowledge from its brief appearance. That's why JUICE will make the most of its unexpected role. That's why Mars orbiters tracked its flyby. That's why ground-based telescopes are already watching, because this is history in motion. A fragment of another system, pulled briefly into ours. By 2027, it will be gone, and the only thing left will be the data. But that data, if we're lucky, might reshape our understanding of how planets form, how solar systems evolve, how matter moves across interstellar space, maybe even how life begins. So when you hear that a comet is passing by Jupiter, remember, it's not just another rock, it's a visitor from somewhere else. A chemical time capsule, an unrepeatable moment in space history, and it's happening now. If you want to stay updated on events like this, missions, discoveries, cosmic firsts, make sure to like the video, subscribe to the channel, and share this story. Because the universe doesn't wait, and neither should we. Right now, as you're hearing this, 3I/ATLS is threading a path through the inner solar system at thousands of kilometers per hour, faster than anything we've built, faster than anything we can chase. Its speed isn't just impressive, it's definitive. It confirms what we already know. This isn't a solar system object, disturbed from the Kuiper belt or nudged from the Oort cloud. This is interstellar. That hyperbolic orbit doesn't lie. It was never bound to the sun. It came in fast, and it will leave faster. Not just a visitor, a drifter, a one-time witness from the galactic wild. Think about what that means. It means this object wasn't shaped by our planets, not sculpted by Jupiter's reach, not tempered by solar radiation. It never orbited the sun, never tangled with Saturn, never swept past Neptune 1,000 times like Halley's comet. It's foreign matter, extraterrestrial in the most literal sense, and now it's in our backyard, just for a moment. What makes it even more valuable is what's inside it. Interstellar comets like 3I/ATLAS carry frozen ices, volatile materials untouched for possibly billions of years. These are chemical fossils, preserved in absolute cold, shielded from radiation, trapped in a kind of suspended animation since before Earth had oxygen, before the moon existed, before the sun was fully formed. And the ice is where the secrets are. Because those ices didn't come from here. They didn't condense in our protoplanetary disk. They didn't crystallize in the same pressure-temperature balance that shaped Earth. They were formed somewhere else entirely. Another system, another cloud, maybe another star. That's what excites the scientists. This isn't just a cosmic snowball, it's a sample return mission that nature delivered to our doorstep. It's the only kind we can get right now. We don't have the tech to go to another star system. We don't have the propulsion, the energy budget, or the lifespans, but we don't need to go to them. Not if they come to us. That's what makes 3I/ATLAS different. It's a piece of the galaxy's distant architecture, arriving unannounced, just once, with no second chance. And now it's heading straight toward Jupiter. There's an irony in that, because Jupiter, the planet that protects Earth from many comets and asteroids, could be the one to destroy this one. Jupiter is the gravitational monster of the solar system. It controls orbits. It bends space with mass. It's 10 times more massive than everything else orbiting the sun combined. It doesn't play fair. It never has. If 3I/ATLAS gets too close, it could suffer a catastrophic breakup, torn apart by tidal forces, dismembered into fragments like Shoemaker-Levy 9. But even that destruction would be data. That's the paradox of this encounter. No matter what happens, fragmentation, deviation, survival, it's a win for science. Because we learn about structure, about resilience, about composition. The way it reacts to Jupiter's gravity will tell us about its density, its cohesion, its internal strength. We'll know whether interstellar comets are loose piles of rubble or tightly bound survivors of galactic travel, and the clock is ticking. March 2026 is when it happens. That's the closest approach, just 54 million kilometers from Jupiter. A glancing pass maybe, or a fatal one, we don't know. But we'll be watching. The JUICE spacecraft will be in position, not because it was planned that way, but because the timing lined up, serendipity. A spacecraft designed to explore moons, now poised to observe an object from another star system. JUICE might become the first human-made instrument to directly analyze an interstellar body up close, beyond Earth's orbit. That kind of observational opportunity is priceless. JUICE will be scanning for molecules, specifically ones we haven't seen before, compounds that defy our models. If the comet vents material as it passes perihelion, melting under solar heat, JUICE might catch it. And if that happens, we might finally get confirmation that some of the organic precursors to life exist outside our solar system. That the seeds of biology aren't Earth exclusive, because here's the deeper question no one can ignore. What if life isn't rare? What if objects like 3I/ATLAS scatter complex molecules throughout space, embedding them in young solar systems, delivering them to rocky worlds like Earth? That's the panspermia hypothesis, and 3I/ATLAS is a natural test case, not because it carries life, but because it might carry the chemistry that leads to it. That's why this comet matters. It's a key to understanding not just where we came from, but how. It's about origin, of systems, of chemistry, of conditions that make life possible. Every measurement we take now could inform missions we haven't launched yet. It could shape the instruments we build in 20 years. It could guide how we look at exoplanets. how we define habitability, how we rank the chemical profiles of other stars. One comet, one chance. By the time it swings past Jupiter and shoots off into interstellar space, it'll be out of reach. Not just physically, permanently. The sun won't hold it. The planets won't loop it back. It will leave behind no orbit, no trail, no promise of return. And that's why the scientific community is moving fast, coordinating across agencies, sharing observations, maximizing every angle, because this is it. 3I/ATLAS is the third confirmed interstellar object, just the third. Oumuamua was the first, and it left more questions than answers. Borisov came next, a more conventional comet, but still deeply alien in composition, and now 3I/ATLAS. But this time we're ready. We've got rovers, we've got orbiters, we've got telescopes. And we've got JUICE perfectly positioned to make contact in the only way we can, through data, through spectra, through signals translated into knowledge. What we pull from this comet could fuel research for decades. It could challenge the assumptions written into our textbooks. It could reframe how we see our solar system, not as an isolated lab, but as part of a wider galactic cycle of matter, birth, ejection, travel, arrival, departure. Interstellar comets are part of that cycle. They prove that material doesn't stay put. It moves. It survives. It evolves. And for a brief moment, we get to watch. We don't get many chances like this. Even with modern detection methods, even with sky surveys and space telescopes, interstellar visitors are rare. They come in fast. They leave faster. Most we never even notice. The ones we do, like 3I/ATLAS, require full spectrum attention. No hesitation, no missed windows. That's what this is. A window. A short, sharp window into another place, another time, another way of building worlds. And that's why it's terrifying, not in the way of threat, but in the sheer magnitude of what it represents. Because we don't control it. We don't own it. We don't even understand it. All we can do is watch it pass. And once it's gone, we won't see it again. Not ever. Once 3I/ATLAS clears Jupiter, it enters the final leg of its journey, a silent, endless departure. No return trajectory, no gravitational loop to reel it back, just velocity and emptiness. A straight shot into the abyss, beyond the sun's reach, into the black between the stars, and it will never be seen again. That's the brutal truth of these encounters. They're final. They're irreversible. They force you to work with what you have, because there is no next time. Every spectrum, every reading, every second of observation counts. Nothing about this is routine. Nothing about it is repeatable. That's why the tension isn't just scientific, it's existential. Because once 3I/ATLAS is gone, it's gone forever. And that's not an exaggeration. Its hyperbolic path guarantees it. There's no hidden curve that bends it back. No slow arc through deep space that might deliver it again in some distant epoch. It will slip the gravity of the sun entirely and vanish into interstellar space. And what's out there, beyond our system? Silence. Cold. The scattered dim light of stars. The same kind of space it's already crossed to get here. 3I/ATLAS may have traveled for millions, maybe billions of years before arriving. Tossed from another star system by forces unknown. Cast adrift by planetary migration, by stellar chaos, by gravitational accidents. No one knows what systems it's seen. No one knows if it passed other planets, other suns, other civilizations. It never speaks. It just moves. And it's moving faster than anything we've ever launched. By the time it crosses Jupiter's path, its speed will exceed solar escape velocity, and then, it enters the deep dark for good. A tiny frozen artifact of another world, slipping through the galaxy like a stone skipped across a black ocean, but it won't leave us empty-handed. Because everything we gather now, every molecule, every chemical trace, every reaction to solar and planetary forces will stay with us, in labs, in models, in databases, generating knowledge that outlives the comet. That's the irony. 3I/ATLAS will vanish. But the story it tells will remain, and the story is vast. It stretches back before our sun ignited, before our planets coalesced, The comet's internal chemistry is a time capsule, older than Earth, older than the solar system, possibly even older than the cloud that birthed it. That's what scientists want to see, not just what it's made of, but how it was made. What forces shaped its core, what conditions allowed it to exist. Because if we can understand that, we get closer to understanding where we came from. 3I/ATLAS is a clue wrapped in silence, wrapped in motion, moving far too quickly for us to ever catch, but not too fast to study, not too fast to learn from. And if JUICE captures anything, any exotic molecule, any chemical ratio that doesn't fit our solar system's profile, it will redefine the baseline. It will show that planetary formation doesn't follow one template. That solar systems across the galaxy might look very different from ours, or startlingly similar. And maybe, just maybe, that the chemistry for life isn't rare. Maybe it's everywhere. That's why missions like these matter, not because they make headlines, not because they spark drama, but because they answer the quiet, dangerous questions, the ones about origin, about uniqueness, about what else is out there. We don't need to go to another star system to get those answers. Sometimes the galaxy sends a messenger to us, and when it does, we don't ignore it. We build instruments. We coordinate agencies. We pull data from orbit, from the surface of Mars, from probes flying through the moons of Jupiter. We squeeze everything we can from a narrow window of time, because it's all we get. We may never see another interstellar object like this for decades. Not one with this path. Not one with this proximity. Not one we're ready for. Because readiness is everything. That's what separates a footnote from a discovery. The fact that we're positioned, technologically and scientifically, to respond, to learn, to record. 3I/ATLAS is not just another comet, it's a galactic artifact, a sliver of somewhere else, and it's offering itself to us for a short time, before disappearing forever. You won't see it with your eyes. It won't blaze across the night sky like a showpiece. But what it carries is more important than a light show. It's the stuff that made us. The chemistry that shaped the galaxy, the kind of thing that reminds us just how small we are, and how much we still don't understand. So we follow it, we study it, we learn from it, and when it leaves, we hold on to what it gave us. Knowledge, possibility, perspective. If you found this story compelling, if you want to track more events that shape our understanding of space, time, and where we come from, then like this video, subscribe to the channel, share it with someone who needs to know what's really out there, because these aren't just stories, they're the real history of the universe, and it's still being written.